Two dice are rolled. A 3 appears on at least one of the dice. Find the probability that the sum of the uppermost faces is greater than 7. Okay, now there's a bit of interpretation to deal with here. Actually, there's always interpretation to deal with, but some of the phrasings in some questions are more obscure than others. The question I got was that second sentence. A 3 appears on at least one of the dice. Does that mean, like, you know, here's my die here, right? If I've got a 3 on this side, does that count as appearing on the die? Like, am I not just interested in the top? Now, I can tell you right now, that's pretty fiendishly complicated. I can tell you right now that is not what they're interested in. I've actually never seen a question. That doesn't mean that doesn't exist, but I've never seen a question that is that cruel to you. Okay, for all intents and purposes, when they say a 3 appears, they mean the 3 is on top. Okay. Find the probability that the sum of the uppermost faces is greater than 7. Okay, now, this is tricky because of interpretation. It's even more tricky when you find out that the answer is 4 and 11. You're like, 11? Like, hold on. It's a multi-stage event, right? So I'm going to be multiplying 2 probabilities together, the one and the other. But this sucker's prime. How on earth do you get 11 out of there? Okay? Now, 11 actually pops out quite easily. And when you see it, you'll be like, oh, right. But to try and get us there, I want to pose this question to you. When we have probability questions, there are 3 and only 3 ways, really, of illustrating the probability that's happening and then being able to pick out favorable outcomes, sample space. Okay? What are the 3 ways? The simplest way? To get the sample space, you just list it. You're like, for instance, you know, if it's rolling one die, you say 1, 2, 3, 4, 5, 6. I listed them. There you go. They're all there. Okay. Listing is the first way. What was the other way? Second way? Dot diagrams. And then the way that we've been dwelling on most has been on probability trees. Right? Okay. Now, here's the thing, and I haven't dwelled on this very much, but a couple of people have come to me with questions like this. Trees on their own are a tricky tool to use. Okay? Because, you know, you can draw lots of different kinds of trees for different questions. Some trees are more helpful than others, and so on and so on. What I haven't spent much time on is the fact that sometimes a dot diagram, for its simplicity, is the necessary first step to get to a good tree. Or sometimes, even the dot diagram itself will be sufficient for you. Okay? Now, when I look at this scenario, I read it again, I know that this is a candidate for a dot diagram because, number 1, how many stages are there to the event? 2. So that's good. Dot diagram can handle that. The second thing is, what's the likelihood of each of the events that I'm going to get? And the answer is, they're all even. Nothing is skewing me towards one way or another, right? The dice, as far as I can tell, are fair. Okay? So therefore, when I draw up this thing, you know, trees excel when you've got different numbers on all the branches, right? But I won't need to have different numbers here. All right, let's have a go at this. 2 dice. What's the sample space? Well, you've got 1, 2, 3, 4, 5, 6. And then you've got 1, 2, 3, 4, 5, 6. Okay, I'm just very quickly going to do the dots. 1, 2, 3, 4, 5, 6. And you can see pretty quickly that there are going to be how many total outcomes? What's the sample space? 36, right? 36, right? Wrong. Read the question again. A 3 appears on at least one of the dice. So now, I started with 36 options, but I don't really have 36 options. I have these options. A 3 appears in all of those. I also have these options. A 3 appears in all of those. Now this looks to me, when I want to know the size of the sample space, 2 rows of 6 minus an overlap. Sounds like 11 to me. Okay. Now from there, the rest of it falls out, doesn't it? What they want is the sum to be greater than 7. So now instead of dots, I'll put in sums. For instance, this sum is 9, 8, 7. That's a dud. I'm not going to bother going any further. Over here, I've also got 9, 8, 7. That's a dud. I'm not going to bother. Now I can see that the favorable outcomes, there's 1, 2, 3, 4. So don't ignore the humble dot diagram. It's very useful, okay? Admittedly, you see the problem is there's no big flashing light that says to you, aha, conditional probability, right? The closest thing is when it says, you know, a 3 appears on at least one of the dice. Sometimes the other phrasing that you will see in questions is, it is known that a 3 is on one of the dice. So there's a condition, Conditions limit the sample space. You don't have 36 anymore, you just have 11.